Today in this lecture, we will study some of the fundamental aspects related to the deformation. Although we are already aware about the deformation from our general observations, but in this lecture, we will see some of the technical aspects related to the deformation. To start with, we can take the example of a rubber band. If you are applying the force on the rubber band such that you are stretching it, and you are not breaking down the rubber band into two parts, so the deformation that is produced in that rubber band will be different from the deformation which is produced in a wooden stick which is broken down into two parts. So what are these deformations in technical aspects? So one of the deformation is known as the elastic deformation and another one is known as the plastic deformation. So rubber has experienced elastic deformation because it has not permanently deformed, whereas the wooden stick, when it has been broken down into two parts, that has experienced the plastic deformation. So elastic deformation we can define as the phenomena that after the removal of the external load, if the material comes back to its original state, then the material has experienced the elastic deformation. Whereas if we have to define the plastic deformation, then we can define it as the phenomena in which breaking of bonds occurs with original atom and new bonds are formed with the neighboring atom. So this phenomena is known as plastic deformation. So figure A shows the elastic deformation, whereas in animation B, plastic deformation is shown. So I am playing this animation video. So for the elastic deformation, here we will see that when the load value is increased, so this needle, when it is moving, it is showing that the load value is increased. So when you are increasing the load value, the atoms are moving in the right direction, means they are experiencing a force, and when you remove the external force, then they come down to its original position. So here the value of the force is not equal to 0. So here you can see that these atoms are slightly tilted. So if you keep the force up to 0, then these atoms will come back to their original position. But in case of plastic deformation, when we are increasing the load, so as you can see, this needle shows that load is increased. Then after the removal of the load, means when the load comes to this 0 position, then you can see that a unit slip step has been produced. This is due to this movement of the atoms, and here what has happened that the bonds of these atoms have been broken down with the bonds which are with the atoms which are lying down the slip plane, lying below the slip plane, and new bonds have been formed between the neighboring atoms. So here after the removal of the force, atoms have not come to their original position. So this phenomena is known as the plastic deformation. If the atoms within the material comes back to their original position, then this is known as the elastic deformation. So there are different modes of plastic deformation. One is tension. So if the force which you are applying on an object, the effect of that force is to increase the length of that object, then that mode of plastic deformation is known as tension. So here you can see this is the rectangular block, and if you are applying force in this topward direction, then this force actually increases the length of the block. So here it is assumed that it is placed on a rigid surface and it is fixed with the rigid surface. So this is the equal and opposite reaction force which is produced here. So here the force is increasing the length of this block, so it is known as the tensile force. But if you are applying the force such that the effect of that force is to compress the material or to decrease the dimensions, say this length has been decreased from L0 to L1, then it is known as the compressive force. And there are shear forces, that if you are applying force to the which is parallel to the cross sectional area, so here this is the force which is applied parallel to the cross sectional area, and the effect of the force is to produce the change in the shape of the object, so that is known as the shear force. So in tension and compression modes, the force is normal force, means force is acting perpendicular to the cross-sectional area. Whether it is tensile or compressive, it will act in the perpendicular direction to the cross-sectional area. And if you are applying force which is acting parallel to the cross-sectional area, then it is known as shear force. So likewise, when you slice a bread or when you cut the ribbon, then the force which is applied through this knife and the scissor will be the shear force, because here you can see the knife is applying a force which is parallel to the cross-sectional area of this bread. So these are the modes of the deformations which are commonly experienced in the material. So if we are dealing with the plastic deformation, then from the microscopic perspective, how this plastic deformation occurs. So plastic deformation occurs due to the slipping of atoms. So when atoms slips, so it produces the plastic deformations. So dislocations which are present in the material, these produce atomic displacement, and these atomic displacements are produced on specific slip planes and in specific directions. Means there are slip planes. On those slip planes, it is easier for the dislocation to move in a particular direction. So combinations of the slip plane as well as the slip direction is known as the slip system, which is responsible for the plastic deformation. As you can see from this figure, that this rectangular block, the left hand side of this block is fixed in this bias, and if you apply force from on the right hand, then you can see the atoms which are placed inside this block, so they are just slipping one over the another. So here you can see this is the unit slip step which is produced due to these atomic movements, and these are the slip planes, means these are the planes on which the movement of the atoms have taken place. Whereas this figure shows, that is figure A is showing the closed packed plane of atoms, whereas figure B shows the non-closed packed plane of atoms. So in figure A, it is easier to move the atoms in comparison to the figure B. So it shows that the plastic deformation is easier to produce in closely packed planes in comparison to the non-closed packed planes. So here you can see that this tangent which is placed below this atom, this shows that if you have to move the atom to the right direction, you have to apply comparatively less force in comparison to the case which is shown in the figure B. And quickly review or if you quickly review the dislocation concept, then we have the edge dislocation, in which we have the extra half plane of the atoms which moves when you apply the shear stress or when you apply the stresses on this lattice. So this dislocation which was present at this position now has moved away out of this lattice, and a unit slip step has been produced. So this can be understood with the simplest analogy of a ripple in the rug. If you have a carpet on the lying on the floor, then the ripple, if you create a ripple, then it will travel from one end to the another end. In a similar way, you can create an analogy with the edge dislocation. So you can consider this as the edge dislocation, which is on the application of force is moving from the one direction to the another direction, and after this ripple has been vanished, then the lattice comes to its original shape. So this is the phenomena which in a microscopic terms occurs when the plastic deformation occurs inside the materials. In elastic deformation also the slipping of the atoms occurs, but the slipping of the atoms can be reverted back to their original state after the removal of the force. Plastic deformation in general is performed on universal testing machine, where we perform different type of tests. So universal testing machine is used to measure different mechanical properties of the material. So during the testing, material is subjected to elastic as well as the plastic deformation based on our requirement. So this is the schematic diagram of a universal testing machine. So here the bottom grip is fixed, whereas the top grip is movable. And here it is showing a tensile specimen which is placed in between these grips. So bottom end is fixed, and if you move the top end, then you will create extension in this specimen, and this is the load indicator. When you increase the load, this length of the specimen will increase and you will create the deformation in it. And this is how nowadays actual universal testing machine looks like. And here this is the environmental chamber. If you have to conduct the test at high and low temperatures, you can also conduct by using this environmental chamber. And this is the display unit which shows the load values as well as the displacement value. So tension test, compression test, shear test, bending test, fracture toughness test, pull out test. So a number of tests we can perform on universal testing machines. So one example of bending test is shown here. So if you have to perform these different tests, you have to just change the attachment which is placed over these grips. Likewise, in the case of bending, we have used a different attachment here. So these two ends are fixed and your load is applied from the top end and it is producing bending in this specimen. So this was all about the plastic deformation, elastic deformation, and how we can relate the plastic deformation with the slipping of the atoms if you have to see the microscopic picture. And these all tests are being performed on universal testing machine. So this was all for deformation. Thank you.